Morning Exercise Science. It's 30th of March, 2020. As we go through the next weeks, months, depending on how long this lasts, I will upload videos just like this one a few times a week, trying to cover some key concepts, communicate key topics with you, and kind of give you an idea of what my expectations are for you and for the course. Our topic currently is the endocrine system. Endocrine system is one that maybe as you think about its relation to the other things that we've talked about so far this year, maybe not quite as important, but in actuality it's an important regulatory system. We did begin discussing it before we left, but to understand how the endocrine system works, how it affects muscle function, very important, and I'm going to go over a few of these things with you right now. One of the major concepts in this chapter is the discussion of the two basic types of hormones, and I've asked you a few questions about some specific hormones, and a number of you picked, growth hormone, PTH, insulin, glucagon. There's a number of different hormones we can discuss, but all of them are going to fall into one of two classes, and those two classes are on the board behind me. We have peptide hormones and steroid hormones, and their basic difference and how they function is based upon their structure. We've talked about that all year. Structure denotes function. The peptide hormones are protein-based, and I'll explain the whole coach and player thing as we conclude today. The protein-based peptide hormones do one thing. They're going to find a specific receptor on a cell membrane. They're going to bind to it, and then they're going to cause a number of reactions to occur inside of the cell depending on what type of hormone they are. So they never enter the cell. They bind to the outside of the cell, and then they cause chemical reactions to occur on the inside of the cell. That's probably the quickest and easiest synopsis I can give to you. Using insulin as an example, insulin is going to bind to the cell membrane, and then it's going to allow glucose to pass through the cell membrane and then react obviously with oxygen and then go through all the processes that we talked about. We summarize as cellular respiration. So what happens when insulin binds, or let's say insulin's not present, and obviously that's diabetes, you can't get glucose into the cell. Or if the receptors don't work, that would be diabetes too, then same net result, you still can't get glucose in the cell. So you need that key, so to speak, to unlock that membrane to allow glucose to move into the cell. In diabetes 1, you don't have the key at all. There's no insulin. In diabetes 2, you have the key, but for some reason the receptors on the cell do no longer fit that key, or the key no longer fits the receptors. You can ask some questions later if you want to use email or Google Classroom about why that is, but I don't want to get into that too much right now. I want to spend some time just discussing this. Bottom line, insulin allows glucose to enter the cell. Insulin itself never enters the cell. It just binds to the cell membrane and causes that series of reactions, again, that we summarize as cellular respiration to occur. Obviously very important. They allow the cell to release energy. Without energy being released in the cell dies. So again, a lot of key concepts brought together here with insulin and glucose metabolism. So I call those a coach. I've heard, actually had a professor refer to those years ago as a coach, these types of hormones, the peptide hormones, because they never actually enter the action. They stay kind of on the sidelines and they dictate what's happening on the inside of the cell. Their presence allows those things to occur, but they don't get involved in the action directly. They don't get involved in cellular respiration. They just kind of dictate what happens on the inside. So call those a coach. They stay on the sidelines. On the other side of the board, we have steroid hormones. Steroid hormones are lipid-based, right? That's a major, when we talk about macromolecules, levels of organization, a major difference. But again, they function in the same way overall as all hormones do. They cause reactions to occur. They cause some type of physiology to be affected somewhere else in the body. So what they do is that they actually pass through the cell membrane and they find a specific segment or sequence of DNA and they bind to that. And what that does is that stimulates or that initiates the process of protein synthesis, which we talked about way back in Chapter 3. Protein synthesis, using genetics as a blueprint to make proteins, which we are made of. So what they do is they actually bind to a sequence or a segment of DNA and then they cause that sequence to produce whatever protein it is made to produce. Good example for that one is testosterone. Testosterone, whether it be androgen-based, which would be more prevalent in females, males have androgens too, but testosterone is typically referred to as the male hormone. What it does is it passes through the cell membrane, it binds a specific sequence of DNA, and then it allows or initiates the production of those muscle proteins. So when people abuse testosterone, when they take what we would call steroid hormones, or steroids for short, they're initiating the production of more muscle protein. That's why people take steroids. Sometimes steroids can be prescribed by a physician. If you have a patient who has some type of metabolic disorder or an endocrine disorder and they're losing muscle mass, a lot of times testosterone is prescribed. And that might be somebody you end up working with someday in a practice as a physical therapist or a trainer. Somebody that has a prescription for testosterone because they're trying to build muscle mass, maybe after a bad injury or some type of disease or disorder, something where they've been bedridden for a while. So a lot of times that is prescribed. I won't say a lot of times, but it is prescribed in some cases. So what you need to understand about a peptide, or a steroid hormone rather, is that they can be referred to as a coach, as a player. Sorry. They get involved in the action. They actually go into the field of play, which would be the nucleus, and they cause proteins to be produced. So again, to summarize real quickly, peptide hormones are coaches. They stay on the outside. They initiate reactions on the inside. Steroid hormones are the players. They actually get involved. They bind a specific sequence of DNA, and they cause some type of protein to be produced, depending on the type of hormone it is. Again, these are the examples that I used: insulin and testosterone. Now, as the week progresses, I'll probably do a few more of these videos, one or two. I'll have some type of assessment. I don't know what that's going to be yet. I don't know what it's going to look like. I'm still crafting these things in my brain. In any case, you'll have some type of an assessment. It might involve some questions. It might involve a small project. I would actually rather go that direction with it, maybe a little slideshow on your part, something that you can show me that you know, apply some of the material that we talked about. And things that I've asked you questions about, rather than just give you a bunch of questions that you could look up the answers and use Google for. I'd rather see some creativity involved with this as well, and maybe application towards exercise science. But again, I'll come up with that and I'll keep you posted. In the meantime, feel free to keep in touch, ask me questions through Google Classroom, through my email address, whatever you prefer. I will get back in touch with you as quickly as possible. Have a good day.